Hello, Stationeers. Today we're going to be going over logic chips. I have some logic IOs, logic switch, logic processor, and memory units. So there's different types of logic IOs. You have the logic reader, logic writer, the batch writer, slot reader, batch reader, reagent reader, batch slot reader, and the logic writer switch. For the math units, you have math unit, compare unit, select unit, a min-max unit, and a urinary math unit. Memory, they only come in one style, and logic switches that can be used to have a switch, have a lever, a little button, or a dial. I'm wondering if I have enough materials for this. I'm not too sure. Maybe you'd be able to tell me. So what you're going to do is you're going to come over here to your electric print, and you're going to scroll down here till you get to logic IO memory processor. And also we're going to cover switches as well. So we're going to print out a handful of each of these items. So first let's go over the dial here real quick. Now it only says I have a value of 0 or 1. Well, how do I increase that? If I increase here, and I can do this up to 100, you cannot use the labeler on this, but now I'm able to increase the dial up to 19. Now the lever is simple. 1 for close, 0 for close, see it says state 0, and open gives it a 1. Same thing for the switch, 0s and 1s. Now the button is the simple activate the button, it gives it a 1, and then it goes back to 0. So how do we operate all this? Well, you're going to need a screwdriver. And the screwdriver is to change these little knobs. I do not have power to these, which I should have. Yes, I do have power available, but it's still showing red. So I just turn it on, and this means there's an error. It means it's not connected yet. But if I change it to the wall light and I want to know if it's on or not, I can turn it on and it'll give me a green light, and it says no, that wall light is not on. Your slot reader will read slots. So if I want to select, which I have nothing on this network, so let's go over here real quick. And there are different items that have slots. The filtration, it has 2 slots. Slot 0 and slot 1. It always starts with 0. So, and the furnace, we have the import slot and the export slot. That's slot 0, slot 1. The furnace, same thing. Import, export slot. So those are the items that have slots, as well as chutes. They have a slot, something where you can put an item into sorters, fabricators, auto lathe, the printers. Those all have slots. Slot reader. Then we have a batch reader. A batch reader will read multiple devices. So if I go to the scroll around here to the light, I can find the light. Batch reader will read multiple items. So as you see, I have 3 memories over here, and I'm going to change them each to 100. Actually, you know what? Let's leave that one at 0. And I am going to select the logic memory. I want to take the average of all the logic memory on this, and I'm going to check the setting. And as you see, the setting is 2/3. So I'm going to change these. I'm going to set this one to 100. I'm going to set this one to 100 and this one at 50. So the average of 250 is going to be 83.3. You can also, I'm going to turn this off just so I don't write to anything I don't want to. I can take the sum. You see the sum is 250. And there are different variables you could have. You could have the minimum. It will take the minimum of all 3 of those, the maximum, and the average. So a reagent reader will read the reagents inside. Say if I have it for the furnace and I dump a bunch of ores in there and I don't remember exactly what I have or how many I have, I can take the reagent reader and it will read it out to me, and it'll say, hey, it has this many of that item. And you can select whatever item it is you want. Say, how much steel is that going to make me? And it will output that and let you know, give you a little reminder what you have. A batch slot reader, it's the same thing as a batch reader and a slot reader combined. Now the math units. We have input 1 and input 2 and add. We can add things, we can subtract, take the power, multiply, the mod, log, divide, attan 2. If you know your geometry and your trigonometry and everything, then you're going to know how to do the log, mod, and attan. I've never heard that one. And I went through trigonometry. I still never heard of attan. So the compare, it will take input 1. Let's just select anything, and we'll take the switch. And we'll take input 2 and the slot reader. Let's go with the logic memory. Now, which logic memory do I have? I have 3 of them here, as you can see right here. And then if you read right here, it's my next item. I have more than one. So if you have multiples on your list, you're going to want to get your labeler out, and you're going to want to label that logic memory anything you want. Logic memory 1 and 2, and then I'll have the third one there. So what do I want them to do? I want them to compare. Do they equal each other? Are they different? Logic memory 2, and we got to get that back to logic memory. Let's do logic memory and logic memory 2. Do they equal each other? No, they don't, so it's going to give me a 0. So what if I make them equal each other? So now 100 and 100, it's going to give me a 1. It can take, do they not equal each other? Anytime it not equals, they'll give me a 1. I can take the less, and I want the less of the 2, and it's giving me a 1, or the greater. Is this one greater than that one? No, it's not. Give me a 0. Is this less? Is logic reader less than batch reader? It's giving me a 1. Then we have a select unit. I don't know a lot about it. I know you could select an item with input. Remember, this is always input 1, select logic math, And notice how I cannot select anything here, and that's because I don't have, this is the data output where the data will go out. This is where it will come in. So you need to have all your data ports connected, and I am out of wires. So I don't know much about this one, but if you notice, I cannot select anything right here, input 2, and that's because I don't have the input connected or the output, so I can't read this item with another item. I have to connect up all the cables, and now I can go through and select an item. So now here we have a min-max, and what we're going to do is we're going to go back and also select that logic reader and the batch reader, and we're going to select which one is greater. It's going to say 210, and that's because 210 is greater than 100. But what if I select the less than? So as things change, you can say, hey, if this is less than, say a tank is less than 100 kPa, keep filling it. You could do that, and then when that gets above, if I increase that, should not be taking the 400. Oh, that's because that's reading the average. So that was a bad example, but you get the idea. And then we also have a math urinary, and you can take the log, floor, cos, I can't remember the name of these, seal, s, the cosine, the tangent, the square root, the sine, round numbers, random, and so on. Like I said, you're going to need your math for that one. Now let's take a look at the logic reader, and what we're going to do is we're going to grab the dial and then the setting. So the setting is 19, and if I change that, I will get a different number. Change the wrong number there. So I can change it to anything I want. So if you want to set something up with that, you can. Now a batch writer. Let's go with the logic writer here. And we're just going to add in a cable here so we can get the logic writer over to the memory, and we want to take it from the logic reader. So we're going to take from the logic reader, and you can take from any of these chips. You can even take from this battery. You can take from anything that this data network is connected up. Now notice how I do not have anything else connected to here. That is an easy way. If you put your chips in a straight line, you only have one option to go through. So I'm going to send that out to the memory. I'm going to send it to memory 1, and I'm going to change that to setting. Now, depending on what you have selected is dependent upon your variable. If I go to the slot reader, I can turn it on, I can turn it off. I can change mode and on with logic select. If I go to the LED, I can lock it, I can change its color, I can turn it on. But we're just going to go with logic memory setting, and I'm going to turn that on, and it's going to tell me 14. So our logic memory is now 14, and I can change that with this dial. Now it's 9. So let's turn that off, and this time now we're going to connect up the logic reader to the batch writer, and I want to select the logic reader. I'm going to output to the memory. Notice there's only one selection for logic memory. Even though these are labeled differently, it still only gives me one option. And I want to change the setting, and I'm going to turn that on. Now all of them should be 9. So that's what you can do with a batch writer. So a logic switch is basically a switch with a logic writer built into it. So you can play around with that on your own. So now what else can we do with a logic writer? Well, let's change this to the dial, and let's change to the LED, and we'll pick on. So right now we're getting a 9. Well, that light just turned on for us. So I can select any one of these, open or closed, or I can use a dial and I can turn that light off. Now there is a slight delay, and that's because the game waits 1 second before to send this signal through. Let's see, we can come over here and we can select the switch, so there we go. On the we'll use the dial as an example. So now what we could do is we could also use this lever, and we selected the lever with the logic writer and this LED on. So now if we use a lever, it turns the lever on, it turns the light on and off. Look like there's slightly less delay. So what else could we do with these? Logic reader, let's go around to the stationary battery. And what we're going to do is turn these off so we don't accidentally write things we don't want to. If you end up locking a device, the only way to unlock it is to set it to 0. And see, like here, I can lock this so that way manual use is out of the question. I cannot manually override it because I've locked it. So you would have to change that in order to manually use an item. We're going to go in and we're going to check the stationary battery. Now there are items that have different modes. The LED display, it has different modes as to how it displays that information. You can show it as a percentage, as a decimal, as e to whatever power. Solar sensors have different modes to them, and there's a few other things that have different modes. So, but we're gonna look at maximum. Let's see what we get. We get a large number. Now, what's that telling us? It's the maximum charge that this can attain. And if we turn that off, we want to lock it. No, we don't want to check if it's basically this is a reader, so you cannot physically lock anything. So it says, is it locked? Yes or no. It'll give out a 0 or a 1. We'll see if it has an error. It does not have any errors. How much charge is in it? And there we can read how much charge is in that battery. So what can we do with that information? Well, we can go over here to the logic writer and go from the logic reader, which is reading the charge, And if we go around here and we select the LED display, we can change the setting and we can turn that on. And if we come over here and turn this on, we'll show 1.6 e to the 6th power. Well, how do we change that? Okay, so what I want to do is I'm going to turn these off, and I'm going to go over to the, we'll take from the logic memory and we'll keep that, but we're going to change its mode. There we go. Okay, so what I've done is I've just reduced a few of the items on here, and I've changed this out, and I've got a couple more logic writers. I'm going to go in from the switch. No, let's go with the dial from here, and I'm going to output to the LED display, and I'm going to change its mode. So its current mode is going to be 0, which is set the standard. So I want to increase that to 1, and you'll notice now it's showing me a percentage of that battery. Well, that's not right. So we'll change there. We have 1.61 megawatts there. And if we change mode 3, it goes back to the default. So we're going to leave that mode 2, and then we're going to go ahead and turn this off, and we're going to come over here and we'll leave that off for a second, and we'll change the look for the dial, and we want to find the LED display, and we're going to change its color. So its current color now is 2, which is green. And if we go through these, there's white for 1, color 0 is blue, and you could go up, and I believe there are 12 different colors. That is not blank, that is actually black. There's white. Oh, we went the wrong way. What is that, like a yellow greenish color? Maybe if I turn the light off, it'd be a little easier to see. So there, you can make pretty colors, do things with that, make a little light show or something. So let's turn this off and let's set flashing light, and we're going to lock it. Its current status is 1. So as you can see, I cannot turn the light on and off. I have to change this back to 0, and now I can turn that on and off. And if we change that to on, so now I change that, and there I can have that on. So what other things can we do with this? Well, we can set AC units to turn on and off automatically. We can read these sensors, these gas sensors, and they check the pressure and temperature. Let me make sure I'm on the right. Wire cables. So we can use gas sensors like this one here, and I've got 4 of them in this room, and we can use it to decide whether or not it's too hot or too cold, and I can turn on my air conditioning automatically. So that way I don't have to mess with it. What we can also do is we could change transformer values. Hey, I want a little bit more power. See, this right here is reading the coolers. It's writing to the coolers 1. This one is writing to the lights. So if I come over here and I flip this switch, I turn my lights off when I leave the room. Save some power. And this is setting to the memory. So this is reading from this because the computer can only write to the memory units. And we can come up here. I have automated solar. And then here you see I have automated heat and AC. So there's my AC unit turning off. In a couple minutes, it'll maybe a few seconds, it turns it on, turns it off, and it's back and forth. I don't have to do anything with it. So just remember, a flashing light, it will turn on. It means there's an error. It's not set up yet. If it's red and not lit up, it just means that it's not turned on. Or it could be there's no power. As you can see, I've got an automated arc furnace here. It's just running. It needs a little kickstart when I put fresh ores in there. But that's reading, and it's outputting a 1 or a 0 if the export slot is occupied, which is this. It'll kick it on if the import slot is occupied. I have to have that in order to get it to reset. So you can automate your furnace from a remote location, so you don't have to go near it when it's like 300 degrees. I can read displays. Now these will read directly from tanks and directly from gas sensors or pipe analyzers. You can also analyze. There was another thing that I had missed. So here I have a network analyzer. And the pipe analyzer does the same thing. And you can see I have actual, required, and potential. Oh, what I can do, cable analyzer, I can require power required. Now this is no longer writing to that. This has been turned off, so I can use this. And I want to pull from the there we go. I want to pull from the logic reader, and I'm going to send that out to the LED light. Is that right? No, LED display. And I'm going to change that to setting, and what I'm going to get is power required. It's requiring me 80 watts to power these 3 items. So if I turn this item off, I get 70 watts. So 35 watts for those 2 items. Make sure nothing else is on. There's nothing else on. And you can also, let's turn this off so this doesn't change. I can put my potential. I get 2 megawatts. So there's 2 megawatts in this battery. And it will constantly change. And let's turn this off. And then the actual is 70 watts. So if I turn on a light, it's going to change for me to 95. And as you see, you can turn things on and off. So the potential is how much potential that battery could put out right now. It has this much in its stored charge. The maximum is if it was fully maxed out. And then the actual is how much am I actually using. There are a bunch of different things you could do with logic chips. It's all about automating your items. Just remember, screw 1 is what you're reading from. Screw 2 could be your variable. It could be what you're writing out to. It literally tells you right on there, out, in, and the variable you want. Depending on what you selected as to what variables you're allowed to see. And if you need to, label everything so you know, hey, this logic writer, I want this to go to my cooler, and I want this to go to my heater. So you know which is which. And same thing with your memory units. If you put them in a single file line, like I usually do, if you put them in single file lines, you see I've originally I did not have this hooked up, but I need it hooked up in order to get, why do I need it hooked up? I don't know. So originally I did not have this hooked up. I just had a straight cable across here and across here, and you can see there's not very many choices on there, so I didn't label them. I already know that that's my only choice, so I'm good with that. There you have your logic chips, your logic memory, and your logic math units. Let me know what you want to see next, and I'll be sure to cover it. And as always, happy stationeering.